le, kau masih jomblo le, padahal aku udah coba nyari-nyari. Kadang suka iri lihat orang kan aku juga pengen rasain
EN 170180. So today I'm gonna present about our group project, which is project vessel design. So I will go to the introduction first. Pressure vessels are used to store fluids under pressure. The fluid being stored may undergo a change of state inside the pressure vessel, as in case of steam boilers, or it may combine with other reagents, as in a chemical plant. The pressure vessels are designed with great care because rupture of pressure vessel means an explosion which may cause loss of life and property. In scenario, the current design of cylindrical pressure vessel is not working and failure to operate due to the lifetime issue. Pressure vessels are in accordance with a SME code. The code gives for thickness and stress of basic components. It is up to the designer to select appropriate analytical procedure for determining the stress due to other loadings. The designer must familiarize himself with the various types of stress and loadings in order to accurately apply the result of analysis. Designer must also consider some adequate stress or failure theory in order to confine stress and set allowable stress limits. The method of design are primarily based on elastic analysis. And elastic analysis is valid up to the range of load under cyclic loading conditions. A factor of safety on the stress or a factor of safety of 20 is applied on the number cycles. Design stress is accepted as the lower value. That's all for the introduction. So next I will pass it to my friend.
Assalamualaikum. My name is Muhammad Shahid bin Shari. My metric number is CN170119. Now I will talk about a literature review. A pressure vessel is a container designed to hold gas or liquid at a pressure substantially is different from the ambient pressure. Consequently, pressure vessel design, manufacture and operation are regulated by engineering authorized, backed by legislation. Pressure vessel can theoretically be almost any shape, but shape made of section spare, cylinder and cones are usually employed. A common design is a cylinder with end caps called heads. Material selection for pressure vessel is carbon steel, carbon manganese steel, low alloy steel, high alloy steel, alternating stainless steel, non-ferrous materials such as aluminium, copper, nickel, alloy, and last one is high duty bolting material. Pressure vessel commonly used for compressed air, storage tank, which is we use water to storage tank or oil, then distillation tower, pressure reactor, and many more.
Okay, Assalamualaikum warahmatullahi wabarakatuh. And I want to present about drawing. Okay, what is FEA? FEA is a method of using virtual simulation technology to test how a product design react to physical effect, including bend, heat, vibration, fluid flow, and other impact. So with FEA simulation tools, we can evaluate design early in the design cycle, determine what will cause premature failure, quickly explore design change to reduce cost and weight, and determine the product's factory of safe. Okay. What is stress? Stress is a physical quantities that express the internal forces that neighboring a particle of a continuous material exert on each other. While Stress is the response of system to apply stress. when a material is loaded with a force, it produces stress, which which then cause a material to deform. So firstly, we draw the simple vessel in SolidWorks, and after complete the design, we select the material, two material, alloy steel and carbon steel for analysis in FEA. What we do to material, alloy steel and carbon steel, we want to make a different material that been used at vessel. So I also have attached the report FEA in the group lab report at appendix. Okay, so thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nabila Rosli. So today I'm going to present on discussion part. Right, basically, design parameter for pressure must follow ASME Division 1 standard. This is due to mainly safety factor and avoid failure. Pressure vessels simply are designed to be used in pressure vessel, boiler, heat exchanger, and any other vessel for that content. Familiar examples include gas cylinder for cooking and for welding, oxygen cylinder for diving, and many of the larger metallic tank in oil refinery or petrochem and chemical plant. There is huge range of different chemical and liquid that used to store in the pressure vessel itself under certain pressure. So differing from relatively burning substance such as mixed palm oil to crude oil and natural gas and gas distillate to highly lethal acid and chemicals such as methyl isocyanates. The material used for the pressure vessel in this lab report is alloy steel and carbon steel, where carbon steel basically provide a number of advantage for pressure vessel material in addition to being highly resistant to corrosion, shock, and vibration. It also possesses high tensile strength. Alloy steel also has high allowable stress. High strength low alloy steel can be used to some service provided that are balanced chemistry in define and optimize welding parameter. The dimension used in this drawing is shown in the figure below for both drawing. The drawing for both pressure vessels in the lab report is drawn using SolidWorks software. So we have run the simulation for stress and strain for both pressure, and the vessel has been very successful. This is due to the thickness has been calculated by using calculation as shown here, which is circumferential stress and longitudinal stress. That's all from me. Thank you.
Assalamualaikum, my name is Iskan Amriz and I'm going to present about our conclusion for this assignment. So first, the early decision to focus on alloy and to concentrate on optimizing alloy composition, characterizing material behavior and developing production scale processing method was critical to the success of this assignment. So basically, technical accomplishment in material characterization in the development of alloy composition include the identification of critical material deficiencies, the characterization of important degradation mechanisms, and the optimization of alloying technology to improve structural performance and processability. So by default, some of the most significant accomplishment of the intermetallic alloy research program had been in development of manufacturing process, such as methods and alloy modification for low cost of casting processes, and materials and processing method for structural welds and weld repairs. So industrial participants have been critical in identifying these needs and priorities. Additional work including welding and machining process development and the development of solidification models for casting and welding process may be needed to accelerate the commercial use of alloy in our pressure vessel. So for the recommendation, we recommend that this alloy or this assignment to continue emphasize the development of manufacturing process technology for selected alloys to maximize opportunities for customizations and technology transfer to industry. Thank you.
Kok manisnya gemas-gemas gitu terngiang-ngiang.